All right, today we're going to do lesson 3, properties of numbers. Some of this stuff you guys have seen last year because we went over it together, right? For example, commutative and associative properties. Yes, we should remember those. We also talked about identity for addition and multiplication, and then property of 0. Now, I am going to give you a few new ones, but we'll move through these fairly quickly because most of us have seen this before. All right? So first one we're going to look at is reflexive property. Okay, reflexive property is the most simple one. It just says if you have A, that you know A is also equal to itself, right? Or if you have the number 6, we know 6 is equal to 6. So reflexive property is simple and straightforward, okay? Can anybody tell me what symmetric property would say?
Yeah.
Okay, so if I have 8 equals 2 plus 6, that's the same thing as saying what?
8 equals 8.
No.
2 plus 6.
It's, there we go, 2 plus 6 is equal to 8. It's like a mirror image, symmetric, okay? All right, transitive property is next. Okay, transitive property basically says this. If we know 6 plus 9 is equal to what?
15.
And we know 3 plus 12 is equal to,
15.
then you could just say 15 is equal to 15. Okay, it basically just allows you to substitute. Not substitute, but okay, substitution we should all know. If we have the n is equal to 11 and it wants you to solve for n, what does that mean you're going to do? Substitute 11 for n. Okay, most of those are pretty straightforward. Yes?
Mm-hmm.
Oh, wait, I think I still see a couple people writing, so I'm going to try not to. Okay, anybody still writing that down? All right, can anybody remind me of additive identity? Cage. Says you can add what number that won't change the value? 0. Identity is always about it won't change the value of whatever you have, right? So a plus 0 is still going to be equal to just a. Now, what about additive inverse? What would be the inverse of A? Good, Nathan. What would A plus negative A be equal to?
0.
0, right? Or you could show 3 plus negative 3 if that helps you kind of understand it better to use a number. 3 plus negative 3 would be 0. All right. What about multiplicative identity? Yes?
Multiply by 0. Or by 1.
There we go, by 1. Remember, for identity, whether it's multiplication or addition, you're adding or multiplying something that won't change the value, okay? What about multiplicative property of 0? This one's pretty self-explanatory. Somebody? Nate? Yeah, anything times 0 is 0. All right, what about multiplicative inverse? Reno, thanks for volunteering.
Let's see here.
I'll give you this.
It's
What would be the inverse of A over B?
B over A.
Okay, and we know that that would always give you what as an answer?
I would always give you 1.
Thanks, Cage.
Yep.
Same thing if you had 4/5 times 5/4. Right? We know 4 times 5 is 20, so it'll give you 20 over 20, which is equal to 1. Yes? All right. Okay, what about commutative property? Commutative property works for two operations. What two operations would those be? Addition and multiplication. Grayson, can you give me an example using addition?
A plus x equals x plus a.
Okay. Can somebody else give me an example using multiplication? You can use numbers.
1 times 2 equals 2 times 1.
There we go. Okay. Commutative property says you can add or multiply, you can switch the order. Add or multiply in any order doesn't change your answer. Does that work for division and subtraction? No. All right. Last one. Associative property. Does anyone remember what associative property says?
You can switch like the number orders,
You can switch what?
like the orders, the where the parentheses.
You can switch where the parentheses are, not the order. So the order still stays the same. Where would the parentheses move to?
Around the B and C.
B and C. Okay. Now, here's two things that'll happen. One, you can never have associative property if you don't have a set of parentheses. But two, sometimes people will see parentheses and automatically think it's associative. And I'm going to show you an example in just a second why that's not always true. Here's one with multiplication. Notice on both these examples, the order of those numbers stay the same. So A, B, and C on the left, A, B, and C on the right. The only thing that moves is the parentheses, okay? So you don't have to write this part down. I'm just going to show you so you know. Sometimes people will see something that looks like this. And say that it's associative because the parentheses moved. Why is this not associative property? Because then the order of those numbers changed. Can anyone tell me what property this shows?
Distributed.
Not distributive. Who said commutative? Why is it commutative, Reno?
Because you change the order of numbers and multiplication.
So you switch the 3 with the parentheses, right? So I took everything in the parentheses and moved it to the front here and then switched that with a 3. That's why that shows commutative property, okay? So just be careful about that because that's honestly the biggest mistake that I see people make here, okay? All right. Here we go. Now, I'm just going to walk through a few problems and tell you why it's important to know some of these properties, okay? So, let's say on this, if I don't have a calculator, this is a simple problem for us to find the answer to. How so?
Because you could do, it's on the second number. Like
Okay, what would you add first, Nick?
25 and 15.
What property says you can add those two and not 25 and 14? Yeah, commutative property. Says you can add in any order, right? So, I know 25 plus 15 is going to give me 40. Okay, what about 14 and 36? Right? Isn't 40 and 50 a lot easier to add?
Yes.
Okay, all by using commutative property. That's the one, honestly, that you're going to use the most. Okay, so same thing if I have, bless you, 3 2/3 plus 4 plus 5 1/3, right? Can't I use commutative property to add what those two mixed numbers first? Yeah, so 3 2/3 plus 5 1/3, please don't say 8. 9, right? 3 plus 5 is 8, so it has to be over 8. Add to get a whole number of 9. All right, what's 9 plus 4?
13.
There's always one. Nicholas. Okay. All right. Anybody have an idea where the easiest place to start here would be? Cage?
12 times 5.
What would 12 times 5 give you?
60.
Okay. Why would that be the easiest place to start?
Because it's 5 multiplying by 12.
Okay. There's really an easier way.
It ends in 5 or 0. Yeah.
Well, true. What other two numbers could you multiply that would end in 5 or 0?
6 times 5.
6 times 5. Here's why. When you get further down, it's just going to make it easier, right? What's 2 times 3? 60. What's 6 times 12? What's 6 times 12?
100.
Just 6 times 12
72.
is 72, right? So all you have to do is add that 0, okay?
720.
Now, again, some of this is just trying to help you think about what order you need to add in. I'll send him. Uh-huh. Of course. Bye. Listen, why don't you just wait, because I'm almost done. Okay? All right. Boys. Okay, if A is equal to -1, B is equal to 4, and C is equal to 6, we're going to solve A minus B plus 5A minus 2B. Okay. Anybody on the other side of the room want to answer this one? The other side of the room? I know y'all do. Come on. Listen, you know I'll call on you if you don't want. Thanks, Abby. Go for it. Okay, tell me what I would get when I substitute.
-1 minus 4 plus 5 times -1 minus 2 times 4.
Okay?
Then you would do multiplication first. That would be -5 and -8.
Okay. Now, is there more than one way you can work this? Yes, right? Does it make most sense to just work left to right? Yes. What's -1 minus 4?
-5,
Okay, and then -5 minus 5,
-10,
and -10 minus 8.
and -18.
Good. Okay. Molly, you wanna give it a shot? What would I do first?
Substitute,
Okay, I'm using these same numbers. Okay, substitute for me and tell me what it would give you.
2 times -1 minus 3 times -1 squared plus 4.
Okay. All right, go ahead.
You would do -1 squared,
-1 times -1 would give you 1. Okay, let's go ahead and do this in the same step.
that would just be -2.
Okay. All right, what would I do next?
-3 times 1 is -3.
Good. So -2 minus 3 would give you And then -5 plus 4. Good. Okay. All right. Last thing we're going to do. Okay. So there's two things I want you to do. The first thing I want you to do is tell me the value of x that would make the statement true. The second thing I want you to do is tell me what property then is being shown. Okay? Grayson.
X equals 0.
That is true. And additive identity. Very good. Remember, identity say you can add anything that's not going to change the value. All right? What about 1/2 times x is equal to 1/2 times 7? Nate.
X equals 7.
Okay, and what property is shown here?
What would be multiply inverse?
There's no inverse though, right? If it was multiple of inverse, it'd be 1/2 times 1/7. Okay.
I was substituting.
No, because substitution would have had to already have told you x was equal to 7. Say it again. Reflexive. Reflexive was the first one we talked about, right? Okay, reflexive property just says if you have one side, it's equal to the other, okay? So if nothing changes, we're looking for reflexive property, okay? All right, last one. 1 times x is equal to 3. Marley? What would be my value for x? Tell me that first.
3.
Okay, and then what property would be shown here?
I don't know if it is. Inverse.
You're close.
Yeah.
There we go. Just remember on inverse, whether it's addition or multiplication, you're going to have something that's the opposite. Okay? Identity says it's not changing the value. Okay? All right. You're going to do page 20. (18 through 28) evens, 32 through 46 evens, 66 and 68. Okay? Hey, make sure if you have questions that you are asking, especially on some of those new properties.